Hi, everybody. This is a quick screencast about some of the things you just saw in the videos that you watched. You were watching some videos that demonstrated physical and chemical properties. And one thing that we really needed to add to those videos, which they didn't really maybe go over as much, is that physical properties can either be intensive or extensive. And by the time you're done with this lesson, I want you to be able to know the difference between intensive physical properties, extensive physical properties, and then chemical properties. Chemical properties are always intensive. So I think you saw in the videos that they were working with different substances. Substances are pure matter, uniform and unchanging composition. And since they always have the same composition, they can be described or identified by a set of properties. Some of those properties are physical in nature and some of them are chemical. Now, if it's a physical property, it's going to be able to be observed without creating a new substance. Like I can look at sugar and say, oh, it's white. I can look at sulfur and say, oh, it's yellow. I could take a block and put it on a balance and say, oh, it's 500 grams without creating any kind of a new substance. So that's a physical property when you can observe it or measure it or see it, and you don't make anything new in the process of seeing that. Now, here's a list of some physical properties. Many of these you saw in the video or in the quick demo at the beginning of class. So take a look at those. Now, this list, while they're all physical, they can all be measured or observed without creating anything new. Okay? It's just like you stick a thermometer in something that's boiling to get its boiling point. Same thing, if it's melting, you stick a thermometer in there and get the melting point. Okay? You can measure the length of a piece of wire without creating anything new. So these are all physical. But the question is, which among these are intensive and which ones are extensive? Now, if it's an intensive physical property, that means that it does not, does not depend on the amount of substance present. Like if I ask you, for example, what's the boiling point of water? You don't have to ask me like how much water is in the pan. Now, if there's more water in the pan, it might take longer to get it to reach the boiling point, but it'll always boil at the same temperature. So that is what we know of as an intensive physical property, because it does not matter how much water is in the pan, the boiling temperature is going to be the same. Now, if it's an extensive physical property, that means it does depend upon the amount of the substance present. Like, okay, how long is that wire? Well, it depends how much wire is present. Do you have 2 inches of wire or do you have 10 inches of wire? Okay, so these two different types of physical properties, what I want you to do is we're going to go back. Okay, see this right here? Go back to the list. I'd like you to write that list down in your notes. And I'd like you to try to identify each one of those as either an intensive physical property or an extensive. So take a look at this list. Now, what I want you to do is pause so you can go through the list and and try to label them. Okay. Notice that intensive physical properties help you to identify a substance. Like if I said I have a clear liquid and it boils at 100 degrees Celsius and its density is 1 gram per milliliter. By the time I'm done with those 3 properties, somebody knows which liquid I'm talking about, that I'm describing water. Because intensive physical properties, since they don't change with the size of the sample, they help you to identify what is the sample. Whereas an extensive property, like, yep, I have 2 cups of that liquid, well, that doesn't help us at all. I could have 2 cups of any liquid. And so volume is extensive. It depends on the amount, and it's really not good for identification. Okay. So you see the list here. Let's see if you labeled them correctly. Just self-check, and then we'll go down through. Okay. Like color, density, melting point, boiling point, hardness, index of refraction, none of those change with the sample size. Like the hardness of a diamond, okay, does not depend on the sample size. You saw the ghost crystal demo. Whether or not, the ghost crystal disappeared in the water did not depend on how big the crystal was. Okay. Melting and boiling point, like ice melts at 0 degrees Celsius, water boils at 100 degrees Celsius. Doesn't matter how much water you have, it's going to boil at 100 degrees Celsius. Water is clear and colorless. Sulfur is yellow. Okay. Now this one, if any of you had this as extensive, that is probably one of the most common ones to get wrong. And the reason is that everybody usually recognizes mass and volume as extensive. I mean, if I have a bigger sample size, it's going to have more mass and more volume. And because density is the ratio of mass to volume, a lot of people think, oh, well, they're extensive. That means density is extensive. But think about this. Like, let's say, for example, that I have, 100 milliliters of water, and I weigh it, and I get the density, the mass to volume ratio. And then I pour another 100 milliliters in my beaker. So I have twice the volume. It's going to have twice the mass. You see what's happening here? Because density is a ratio of 2 extensive properties, density itself ends up being intensive. And so it's very good for identification. This is, basically how, like in the gold rush, in the Western gold rush, how they knew if they actually had a nugget of gold, or if they, had a nugget of fool's gold, which is like an iron pyrite that kind of has a goldish color, because of the density. Pure gold has a density of 19, and that's a random line there, 0.3 grams per milliliter. So, if they had indeed had pure gold, this would be the density. And that's how they separated it when they're panning for gold. It would go to the bottom of the pan. And that's how they identified and, certified that it was pure gold, is using that density. So hopefully that helps you to sort out the difference between intensive and extensive. And then remember, chemical properties. Those describe how a substance behaves or fails to behave. Is it flammable? Is it corrosive? Is it caustic to metals? Is it toxic to humans? And so here's a couple of examples of chemical properties. Like when iron rusts in the air, that's iron combining with oxygen from the air. So it's making rust. Helium is not flammable. That's why we use it in party balloons. We don't fill our party balloons with hydrogen. They'd float, but they would also ignite. You ever try to melt sugar? You can't. It decomposes when heated up. If you ever tried to melt sugar, you end up with like a terrible tasting blackish brownish goo in your pan. And that's because the sugar decomposes and it's leaving some carbon behind that doesn't taste so good. Copper tarnishes, anytime you get a brand new penny, you let it sit out. It's going to take a while, but it'll tarnish. Now, platinum, that's metal that doesn't tarnish. That could sit out for years and years. It's not going to react with oxygen from the air, so it's not going to tarnish. Argon is inert. Argon is a gas. It is in the far right column on the periodic table. This is a nice vocab word for us. Inert means unreactive. Okay? Those gases that are in the far right column, they don't react with anything. And the fact that so many metals react with oxygen is why they can't put air in a light bulb. They have to fill a light bulb with argon because, the argon, when the little filament gets hot, the little filament, that metal filament inside of the light bulb, it will not react with the argon. And you might say, well, why the argon? All those gases on the right side, helium, all of them, they're all unreactive. But argon is the third most abundant gas in our atmosphere. Nitrogen and oxygen make up like 99% of our atmosphere. And the other 1%, the biggest contributor to the other 1% is argon. So it's fairly plentiful, and it is inert, meaning that it is unreactive. So it'll have a special use, like inside of a light bulb. Okay? So hopefully you can tell the difference between physical properties that can be observed without creating something new and chemical properties. These tell how substances do or don't react with one another. And you can tell the difference between intensive and extensive physical properties. If it's intensive, it does not depend on how much of the sample is present, like ice melts at 0 degrees Celsius. If it's extensive, it does depend on how much of the sample is present. Okay, I have a kilogram of ice. So that would be extensive because that's the mass. Okay, and so you're going to get some practice at doing this in the next few days. And, make sure you seek some help if you need it, or rewatch this or the videos. All right. Have a great day.